Assalamualaikum and good day to everyone. My name is Muhammad AKASHAH bin SHAMSHUDDIN and my MATRIC number is 207271. In this video, it will be about my lab test of ECC3115 or Group 1 Electrical Circuit Analysis. So as a starter of this video, I will briefly explain my understanding of this circuit diagram. So first, when a switch is closed, that means at t less than 0, there will be no current that will flow each of this branch. So when there's no current that will flow each of the branch, that means the discharging process will occur and the value inside of the energy stored in the capacitor will restore into the initial value. And when the t is greater than 0, that means the switch is open and the current will flow from the DC current into each of this branch. So the charging process will occur. So next, I will construct the circuit in the multi-scene software. To construct the circuit in the multi-scene software, we need to know what are the components in the circuit diagram. As you can see here, there are about 5 components, which is the first one, DC current, switch, capacitor, inductor, and also last but not least is the resistor with the 3 different values. So I will construct the circuit in the multi-scene software. Stay tuned. Okay, now I will briefly explain about the function of the current clamp itself and also the oscilloscope. So now as you can see here, the function of the current clamp is to read the current that will flow into the branch here, that will flow into the inductor. So here, as you can see, the ratio of voltage to current is 1 volt with 1 milliampere. So that means if I change to maybe 3, so that means there is a flow of 3 voltage with 1 milliampere. So in this experiment, in this lab test, I will change to 1 reading, and the voltage will read the voltage. The oscilloscope will read the voltage. So before that, I'm going to change the channel A scale into 10 so that we can see clearly later, and also time base with scale of 100 microsecond. Right. So now it is a state of when t is less than 0. So later when I change to t is greater than 0, as you can see here, there is a change in the graph here, in the graph of voltage here. So as you can see here in the simulation part, and I'm going to put it into here, and as you can see here, the value at T2, and it exceeded the amount, the maximum current that flows into the circuit, and it is already 24.055 volt. So that means in this simulation 625 ohms is actually under damped. I'm going to show you. Right. So now I'm going to verify this graph of simulation with my calculation. Here, as you can see, for the resistor at 625 ohms, I will have to find the resonant gradient frequency and also the Nepal frequency. to determine whether it is under dam, critical dam, or the over dam. So here, when I find out the value of resonant gradient frequency is greater than Napa frequency, that means the root of the characteristic equation are complex. Thus, it is under dam step response. So we are going to use this formula here by theories to plot our graph later. So as you can see here, the graph of the of the underdam, which is the 625 ohms resistor, is this one. And as you can see here, the reason why it exceeded the amount maximum current, it is because the underdam will overshoot the graph, and at the end it will converge into the 24 milliampere later. So now I'm going to multiply this circuit with another 2 so that we can see the differences between another 2 reading of resistor. So I'm going to paste this. So I'm going to change the color so that we can see the differences. So now I'm going to change the value with 500 ohms, and also down below here with the 400 ohm resistor. So now I'm going to simulate this, but I'm going to check this one by one of oscilloscope. So I'm going to run this simulation, and I will change to the switch into the open. So I'm going to change the value of, I'm going to set up the T1 and T2 to determine the value. So when the T1 is 12.534, right, and also 12.630. So as you can see here, this is the oscilloscope of 625 ohms initially. This is the oscilloscope graph of 500 ohms, and last but not least is the graph oscilloscope of 400 ohm resistor. So I already set up the value T1, T2 at the same value at the same time of time base of T1 and T2, so that I can differentiate the value, the difference in value of voltage here. So when the differences is 109.519, and it just closes as around like that, and the value of 625 ohms is 24.045 volt, which is already exceeded, which is we convert into the ampere, which is 24.045 milliampere. So it is already exceeded the maximum current. And for the 500 ohm resistor, it is already 22.100. It is actually not exceeded the maximum current. And last but not least, the 400 ohm resistor is the 19.994 milliampere, which is below than the 500 resistor. So that means from the simulation itself, I can conclude that 625 is the underdamped, which exceeded, which overshooting occurs, and 500 ohm resistor is the critical damp, which is the middle between the underdamped and also the overdamped. And also the last part is a 400 resistor, 400 ohm resistor, which is the overdamped. So I'm going to clarify with another two graph of 500 ohm resistor and with the 400 resistor with the calculation and also my own plot in the Desmos website. So by theories, the resonant radiant frequency is equal with the Nepal frequency. That means it is critical damp, and I'm going to use this equation to plot my own graph later. And also the resonant for the 400 ohm resistor, the resonant radiant frequency is lesser than the Nepal frequency because the root of the characteristic equation are real and distinct. So it is overdamped step response. So I'm going to use this equation to plot on the graph later. So as you can see here, this is the 500 ohm resistor, which is the critical damp, and also the third graph is the 400 ohm resistor, which is the overdamp. Since the underdamp the overshooting will occur at the underdamp, that means it exceeded the amount of the maximum current. So this verifies that the graph at Desmos using the theories and the graph at the simulation of multi-software are identical. So that means in conclusion, I will have to say that the best rating of resistor is the 500 ohm resistor because it is critical damp between the underdamped and also the overdamped, and also the most suitable because it doesn't exceed the amount of maximum current, and also it will converge at last with the 24 milliamp. That's all from me. Thank you for watching.